Hello, hi, good morning students. I am Krina Dayani and I am your chemistry teacher. How are you all? I hope you are doing well. So, in our previous lecture, we have discussed about the electronic configuration, which is basically the arrangement of electrons in the particular shell, and we have discussed the electronic configuration of the sum of the elements in our previous chapter or previous class. Now, we will going to discuss about more elements electronic configuration in our today's lecture. So, we will write the electronic configuration of certain elements. We will write the electronic configuration of certain elements numbering from 11 to 18. So, now we will learn electronic configurations of the elements having atomic number between 11 to 18. So, firstly, we will write the atomic number here. Now, we have the name of the element. Next, we have number of protons, number of electrons, number of neutrons, electronic configuration, and lastly we have the atomic structure of that element. So, now we will discuss about the elements having the electronic configuration, and now we have the elements between 11 to 18. So, firstly we will write about the name of the elements, how much protons it will constitute, how many electrons does it have, number of neutrons, their electronic configuration, and about their atomic structure. So, the first element we have in this series is, first element having atomic number 11 is sodium, and symbol for sodium can be written as, it has been derived from a Latin word that is natrium. So, we have a symbol Na for sodium, and sodium is having an atomic number 11 and having an atomic mass 23. So, the number of protons will be the atomic number of that element. Number of protons 11, number of electrons 11, and number of neutrons will be calculated by subtracting 23 and 11. So, what we will get here, we will get 23 minus 11 is equal to 12. Now, what will be the electronic configuration for sodium atom? As we know that its atomic number is 11, so its electronic configuration will be 1s2, 2s2, 2p6 and 3s1. It means 2 electrons in the first orbit, 2, 6 and 1, and the sum of all this will give us the 11. So, if I consider about the KLM shell, what we will have? We have 1 electron in K shell, 2 plus 2, 4 electrons in the L shell, and we have the 3s1 here. So, next we have 8 electrons in the L shell, because L can accommodate maximum of 8 electrons. So, 1K, 8L, now 8 plus 1, 9. So, again we have the 2 electrons left over here. So, 2 will be accommodated by M orbit. So, the electronic configuration will be 2, 8 and 1. Now, we will draw the atomic structure of that element. What we will see here, firstly it constitutes a nucleus. In nucleus, we have 11 protons and 12 neutrons. So, we can write 11p and 12n. Now, we will draw the atomic structure of that sodium. So, we have firstly K shell. Here we have L shell. and now we have here M shell. So what we are seeing here, in K shell we have a maximum of 2 electrons here. So in K shell we have 2 electrons. In L shell we have 8 electrons. And finally we have the KLM shell. In M shell we have only 1 electron over here. So this is actually the electronic configuration for sodium. Now proceeding to our next element, after sodium we have our next element that is having the atomic number 12. In atomic number 12 we have element magnesium. For magnesium we know that the symbol is Mg. It is having a mass 24 and atomic number 12. So we can write it as 12 Mg24. Now number of protons will be the atomic number of that element. So number of protons here will be 12. Number of protons and number of electrons are same for the neutral atom. So again we have number of electrons 12. We want to calculate the number of neutrons. The number of neutrons can be calculated by subtracting 24 and 12. So what we will get here, we will get 24 minus 12 equal to 12. That will be the number of neutrons. Now we want to write the electronic configuration of that element. What we will get, 1s2, 2s2, 2p6, 3s2. The sum will give us the 12. Now again we have 2 electrons in the K shell, 8 electrons in the L shell. Now we have 2 electrons in the M shell, and the sum will give us the 12. That will be the atomic number of that element. Now we want to draw the atomic structure for this element. What we will do? Firstly, we will draw the nucleus in the center. The nucleus will constitute 12 protons and 12 neutrons. So we have 12p and 12n. Now we will draw the orbital diagram for this. Firstly K shell, next we have L shell, and in the third we have M shell. Now what we see here is, in K shell we have 2 electrons, so we will fill 2 electrons in the K shell. Now in L shell we have 8 electrons, so 8 electrons must be accommodated in this. And in the last M shell we have 2 electrons, so 2 electrons can be filled by this way. So it is all about the electronic configuration of certain elements. The elements numbering from 11 to 18 can be written in a similar way. Now lastly we will consider the atomic number 18, that is for argon, and write the electronic configuration for it. So I am considering the element number 18. Element number 18 we have is argon. Argon is having a symbol Ar, having a atomic number 18 and atomic mass 36. So what we see here, the atomic number will be the number of protons. So number of protons here are 18. Number of electrons again here are 18. We want to calculate the number of neutrons. Number of neutrons will be calculated by subtracting both these terms. So 36 minus 18 will give us 18. Now we want to write the electronic configuration for argon. So electronic configuration will be 1s2, 2s2, 2p6, 3s2. What it will give? 6, 8, 10 and 12. We are again left with the 6 electrons here. So it will be 1s2, 2s2, 2p6, 3s2, 3p6. Now the sum 18 is completed. Now we can write it as a, we have a 2 electrons in the K shell, 8 electrons in the L shell, and again we have M shell, it can accommodate a maximum of 8 electrons. So we have 8 electrons in the M shell. So its electronic configuration will be 288 because M shell can accommodate maximum of 16 electrons as we have discussed in our previous class. Now we will draw the atomic structure for this model. Atomic structure for argon I am drawing here. Again we have nucleus in the center. The nucleus will accommodate the protons and neutrons. So we have 18p and 18n. Now we will draw the atomic structure for argon. What we will see here, firstly it contains 2 electrons in the K shell. So 2 electrons will be accommodated here. 8 electrons in the L shell. So we have 8 electrons in the L shell. Now again we have 8 electrons in the M shell. So 8 electrons will be distributed over here. So this will be the atomic structure for argon having an atomic number 18. Similarly, we can write the electronic configuration of an element in this way, having occupancy of K shell, L shell and M shell, and draw the atomic structure as follow. If someone wants to copy it, please copy it now. So, in our today's lecture, we have learned about the electronic configuration of certain elements. Now, we will go through our next topic, that what are the applications of electronic configuration. So, we are with our new topic, that is electronic configuration. So now we are with our next topic. What is the significance of electronic configuration? So students, every topic or every particular element we have read, it has its certain importance in chemistry. So what is the significance of writing electronic configuration? So after learning electronic configuration, what we will get from here? So after learning about electronic configuration, we can decide which metal is reactive, which element is less reactive or more reactive. So firstly, electronic configuration will tell us about the reactivity of the metal. So first significance is reactivity of element. From writing electronic configuration, we will able to learn how much element is reactive or not. So how will we determine the reactivity of an element? Suppose we are writing the electronic configuration and we will get 8 electrons in the outermost shell. 8 electrons in outermost shell. If it constitute 8 electrons in the outermost shell, we can say that its octet is complete. So 8 electrons will determine the octet of an element. if an element has 8 electrons in the outermost shell, these are considered as a non-reactive elements because they are stable. They do not need any extra electron to gain or lose. So, if an element has 8 electrons, its examples are noble gases. We have certain noble gases which have 8 electrons in their outermost shell, and these noble gases are helium, argon, neon, xenon, krypton and radon. These are some of the noble gases. These have 8 electrons in the outermost shell, but here helium is an exception. It only has 2 electrons in the outermost shell. So exception here is helium. Helium is exception here. It only have 2 electrons in the outermost shell. Except helium, all the elements present here have 8 electrons in their outermost shell. It means we can say that they have their octet complete, and these are considered in the category of non-reactive elements. So, noble gases are generally non-reactive, right? Now, if we see atom has 2 electrons in the outermost shell, it means having 2 electrons, its quota is fully complete. So, we can say that an atom has a duplet. So, what we see, if element has 2 electron in outermost shell, 2 electrons in the outermost shell, we can say that its 2 electrons quota is complete, and we can consider it as a category of duplet. Duplet means having 2 electrons, and octet means having 8 electrons. So, elements with 2 electrons in the outermost shell can be considered in the category of duplet. So, if the atom has 8 electrons, we can say that these are non-reactive elements. If it has electrons other than 8, we can say that the elements are reactive. So, electronic configuration basically tells us about the reactivity of an element. So, in general form, we can write, if an element have 8 electron or other than 8 electron, what we will say about it? If an element is having 8 electrons, it is non-reactive, and if it is having an electron other than 8, we can say that the element will show some sort of reactivity. So, this is the generalization for reactive or non-reactive element. Now, what is the another characteristics of writing electronic configuration? Electronic configuration will tell us about the nature of the element. So, our second topic after reactivity will be the nature of the element. So, second significance of electronic configuration is that it will tell us about the nature of element. So, how will we determine the nature of the element? If in the outermost shell of an atom there is 1, 2 or 3 electrons, we can consider this in the category of metals. So, if valence shell has 1, 2 or 3 electrons, we can count it in the category of metals. But hydrogen and helium are exception here. Hydrogen and helium have only 1 electron in their outermost shell, but these are not metals, these are non-metals. So, we have one exception over here. Exception is hydrogen and helium. These are basically non-metals. So elements having 1, 2 or 3 electrons in their outermost shell are considered as metals, and those having 4, 5, 6 electrons are considered as a non-metal. So, but this is an exception here. Hydrogen and helium. Now, if the valence shell has 4, 5, 6 electron, if valence shell has 4, 5 or 6 electron, we can say that these will be the non-metals. So, 1 to 3 electrons will be considered as a metal, and the element having 4, 5, 6 electron will be considered in the category of non-metals. So, it is the significance of electronic configuration. Now, we are with our next topic, that what will be the valence electrons or the valency of an element. So, what do you mean by valence electron? What will be the valency of an element? This topic I have discussed in chapter number 3, that is our atoms and molecules. But I will remind you for a quick revision here. What are actually the valence electrons? Valence electrons are the number of electrons present in the outermost shell of an orbit. But what is the value of valence electron here? The valence electron will tell us about the nature of the element, chemical reactivity of the element, and the chemical bonding between them. So, what actually are the valence electrons? So, our topic is valence electrons. What are valence electron? Valence electrons are the number of electrons present in the outermost shell of an atom. Number of electrons present in outermost shell of an atom. So, this will be can be understood with the help of a simple example. Here I am considering the example for sodium. Sodium having symbol Na and atomic number 11. Sodium is having atomic number 11. Now I am writing the electronic configuration of this element. What will be the electronic configuration for sodium? It will be 2, 8 and 1. 2 plus 8, 10 plus 1 will give us 11. Now we will draw the orbital diagram for sodium. In the center we have nucleus. We have 2 electrons in the K shell, 8 electrons in the L shell and 1 electron in the M shell. So, we can draw it as 2 electrons in the K shell, 8 electrons in the M shell and we have 1 electron in the N shell. So, this is our K shell, this is our L shell and this is our M shell. So, we can clearly see here there is a 1 electron left in the outermost orbit of an electron. This is 1 electron left and it is present in the outermost shell of an electron. So sodium is having a valence electron that is equal to 1. So for sodium, number of valence electron will be equal to 1. So valence electron will tell us about the atom or electron that is present in the outermost shell. Now we will proceed to our next term, that is valency. Valency is somewhat related to the valence electron. Valency means combining capacity of an element. So now our next topic is valency. So what actually the valency is? Valency is the combining capacity of an element. Valency is combining capacity of element. Now, valency is somewhat related to the valence electron. If I consider again the example for sodium, we see here it has 1 electron in the outermost shell. If I want to complete the octet of a sodium, what I want is, it has 1 electron in the outermost shell. Now, if I want to complete its octet, I need 7 extra electrons. I need 7 extra electrons to complete its octet. So, its octet will be 8. In an 8, it will complete its octet. So, combining capacity means how much extra electrons it will be needed to complete its duplet or octet. Now, after valency and valence electron, we will calculate the example for chlorine. Now, I am considering the example. Our next example is chlorine. Symbol for chlorine will be Cl, having an atomic number 17. How can we write its electronic configuration? Its electronic configuration is 2, 8. It means 2 electrons in the K shell, 8 electrons in the L shell. Now remaining 7 electrons. 7 electrons will be accommodated in the M shell. So this is the basic electronic configuration for chlorine atom. What we see here, it has 7 electrons in the outermost shell. So these are actually the valence electron, and if I need to complete its octet, I will need 1 extra electron. So 7 is a valence electron and 1 will be the valency of an element. So we have a generalized formula for calculating the number of valence electron, that is we will have a general formula for valency. If I want to calculate the valency will be equal to number of valence electrons, but it will be only for the atoms having element or electrons 1, 2, 3, 4. But if I want to calculate the valency of higher elements, so again we have a formula, valency equal to 8 minus number of valence electrons. 8 minus number of valence electrons. This formula will be considered for the atoms having atomic or valence electron 4, 5, 6, 7. So these are the two basic formulas for calculating the valency of an element. And why are we calculating the valency of an element? To see the nature of an element, reactivity of an element, and see the nature of bonding between them, whether they form the ionic bond or covalent bond. So this is a generalized formula for calculating the valency of an electron. So we have completed our topic, that is electronic configuration, valence electrons and valency. Now we will start our new topic, that will be the mass number and atomic number.